This is a short video demonstration of a man-in-the-middle attack. So first I'm going to go through the basic principle or the basic idea, and then we are going to go into the actual demonstration. So what is the man-in-the-middle attack? So this attack is sometimes referred to as the evil twin when it incorporates a Wi-Fi spoofing. Generally this was an attack that you could do in a internet cafe, where you would pose effectively as the internet cafe's free Wi-Fi, allow customers to connect to your machine. You would then connect to the cafe's Wi-Fi and get them onto the internet, and you would sit in the middle, therefore being able to view all the traffic going between the customers of the cafe and the internet without their knowledge. The idea is simple. To get each target, both the victim and the router, to believe that you are the other device. So effectively you become the target or the victim's machine, or as far as the router is concerned, and the target would believe you are the router. This is done using what we call ARP spoofing or ARP poisoning, and ARP stands for Address Resolution Protocol. You get the internet protocol and the media access address of both devices, and then pretend you are in control of them, so both the IP and the MAC address. So just to go into it a little bit further of how this actually works. So the man-in-the-middle attacks are probably the most common and potentially the most dangerous goal of ARP poisoning. And by ARP poisoning, what we're trying to do is that there is a cache on each machine of where it stores all the MAC address against the IP addresses. So similar to how DNS works, in the sense of having a URL linked to an IP, ARP will actually link an IP against a particular MAC address. So the attacker sends falsified ARP responses for a given IP address, typically the gateway, the default gateway or the actual router, and you're basically telling any machine that asks who the router is, you're actually saying, I'm the router. This causes the victim's machine to populate their ARP cache, or in other words their database, with the MAC address of the attacker's machine instead of the one of the local router. And then the victim's machines will then incorrectly forward network traffic to the attacker. So there are various tools to do this. One of the tools we're going to look at today is something called Ettercap, and this allows the attacker to act as a proxy, viewing or modifying information before sending the traffic to its intended destination. To the victim, everything may appear as normal. So we're going to have a quick look at how this can be done. So to do so, first we're going to have a look at the attacker's machine. So as I swap over to the attacker's machine here, and first of all we're looking to get the IP address of this machine, and we're showing that for ETH0, which effectively is the Ethernet connection of this machine. And we can see here the IP address, which is 192.168.0 and 32. But more importantly, we can take note of the MAC address here, which is 080027C7E136, and that is the MAC address for that particular adapter. So if we were to have a look at the target's machine, so if I just swap over to the target's machine, you can see here that the IP address is 37, so it sits on the same subnet as our attacker. But you can also see the IP address of that machine also given here. Okay, so again 0800279F2F EF. So that's the MAC address for this adapter on this particular machine. If I was to do an ARP and have a look at the addresses it currently holds for other machines on the network, you can actually see here that for each of the machines, so it's got the one, the attacker's machine's MAC address here, but also it's got the gateway, and it's also got the MAC address for that, and this is the one that we're looking to actually change. So I'm going to swap back to my target machine, my hacking machine first of all, and just to confirm, if I was to enter here ARP, you can actually see here that there's the IP address and there's the MAC address for that machine, and equally for 37 you can also see there's the MAC address for that machine there. So this is what we're looking to see that will change. So to start this attack off, first of all we need to start ARP poisoning, or address resolution protocol poisoning, so we can actually poison the actual cache of both the router and also the victim's machine. So to do that, we're going to do a sudo, and we're then going to use the app etacap. If this isn't already installed, you can install this from the repository. We're going to use etacap, and rather than use it in GUI mode, we're actually just going to use it as text. So for that we use -T, and that keeps it in text mode. We will also do -S, and that will make sure effectively we're not using or doing anything using SSL, so there's no we're not worried about encrypted communication. -i, this basically allows us to specify which Ethernet we're going to do the ARP poisoning with, or which connection or which adapter. So a machine could have multiple adapters, so we're being specific here to the adapter we're going to use to actually be our man in the middle. M is a man in the middle attack, and the mode that we're going to work on is ARP and then : and then remote, and effectively we're actually using this machine, it's not directly connected to either the victim or the router outside of the network, so everything's been done across the network. And then we put in, first of all, the address of the target number 1. So the target number 1 for us is the actual router itself, and you can see here that I've done / and then the IP address of the router, and then 2 / after it to mark the end, and that basically signifies this is target 1. Next we look at target 2, and target 2 is 192.168.0.37, which is the IP address. If we remember, it's the IP address of our machine. So there you go, it's actually 37. So we are looking at the target address of our victim, and that is our second target. So this is our first and this is our second target, and notice we have 1 / to mark the beginning and 2 / to mark the end. So once this is done, what we can now do is press enter here. We put in our admin, and the ARP poisoning will now begin. So what will now happen is effectively the router's been told that our machine is the victim, and the victim has been told that our machine is the router. Okay, May take a second or two for it to get going. So if I now switch back to our target machine, and if I do ARP, what we should see now is that is our machine first of all, and you can now see that the gateway is also the same MAC address. So the MAC address has effectively changed for both machines. So basically telling you that the device is now pointing to our attacking machine. So if I now swap back here, and you can see that ARP is now taking over, and it has to keep doing it over and over again because the router will take back control given half the chance. So by it repeating and going into a loop, making sure that the cache is being poisoned, it will ensure that we maintain the position of being in the middle. So if I go to a new tab here first of all, and if I do there, so you can see there's our address here, and you can see our IP address is 32. And if I do ARP here, you can see that on the victims on this machine, we can actually see that that is the original address of our gateway, which is a 48 number. So if we just quickly check back with the victim, and you can see that the gateway is a completely different address. So it's a 36 ending here, but here it's not a 36 ending, it's a 58 ending. So clearly ARP is now working. Okay, so now that we've done that and we've actually set up manning in the middle, we can actually execute from here WireShark. And if I execute WireShark here, give it a second to get installed, and then you can see we can pick any of the adapters, and we're going to pick the ETH0, which is the adapter that we're running our ARP request or ARP spoofing on. And then here we can see this is all the traffic that's coming through that particular adapter, and effectively this adapter will see everything that's going across this network. So one of the first things I'm going to want to do is I'm going to want to filter out a lot of this traffic. So the first thing is I'm going to do ip.addr, which is IP address, equals 192.168.0 and then 37. So hopefully that will start to show our target. So I'm just going to make sure that I've got the right address here. So you can see it's 37 here. And you can start to see that some traffic is starting to go through. But because we're not actually doing anything at the moment on that machine, the traffic is very slow, if anything at all. So what I'm going to do is I'm going to do something simple first of all. First I'm going to ping 192.168.0 and 32. I'm going to do that 4 times. And then I'm going to do 192.168.0 and 1. And again, I'm going to do that about 4 times. Missed the the ping command. There we go, that does that 4 times. And now if we look back at the WireShark, you can see now that we actually have some ICMPs, some ping echoes going from our address here. Okay, so that then shows us that we're actually seeing everything, all the traffic that's coming just between the router and this machine and vice versa. So the next thing that I want to be able to do is, I don't want to see all of these packets. What I'm really interested in is the HTTP traffic. So that's what I'm going to do, and for that I'm going to do ampersand HTTP, and if I press enter you can see that it filters, and again we're met with a blank screen. So there's nothing much going on HTTP, and this is pretty much correct because we're not actually surfing the internet or looking at anything that's generating this type of traffic. So if I switch back to my Victor machine first of all, and I'm actually going to close this window and I'm going to open the browser, and off camera you can't see it, but I can actually see that traffic is being generated. So straight away we can actually start to look at the traffic here, and I'm actually going to go to a vulnerable website that actually specifically transmits in HTTP. So it's www.vulnweb.com, and it just gives us some vulnerable websites that we can have a look at. So I'm going to just go through a couple of these. So the first one I'm actually going to do is this second one here, and the reason I'm going here is because I can actually go to the sign up, and if I enter the password username test and the password test and go login, don't save it, then all of this information that we've captured here will actually appear in our WireShark, and I'll show you that in just a moment. So I just want to try some other users. So admin, nothing there. So rich, again, nothing else there. If I go to your profile, you can see that there. Guest book. I'll just do that there, add a message. Again, add another message here. And then we can log out here, and then just for good measure let's log back in. Let's try test again. So all I'm doing is generating some traffic. So now I've sort of tried that one out. We can have a look at some other pages here. So this one's using IIS. Get some dates. And then let's do a test on this page. Nothing here. Admin. So I'm just using basically this page to generate some HTML traffic. So this one's sign up, so I'll try Rich to sign up. Subscription has been done. Get RSS feed. Okay, so that's generating some information there. Let's try that again. Might not work. I'll try it anyway. Yeah, nothing much there. Network scanner. And you can see that's gone to HTTPS, which is no use for us. Okay, so I think we've done enough here to actually generate some traffic. So I'm going to swap back to the actual Kali machine, and straight away you can actually see that there is a number of responses here. Okay, so we can actually start to look at the individual packets, and you can actually start to get some useful information. You can actually see that in clear text over here. Okay, and you can see all of our traffic that we've generated of being captured. So what I'm going to do at this point is I'm actually just going to stop WireShark. So that will stop it, and we can actually have a look through here, and you can see everything that was done. We can see some HTTP traffic there. So one of the things that I would do at this stage, just if I actually first of all look at some of the other bits of information that we may have captured here. Not looking at that so much. I'm going to look for some HTTPS, which you won't see any HTTPS actually, because I am actually got a filter on. If I was to take that filter off, you would actually see that there'd be some HTTPS traffic. So let's just remove that filter for a moment. So this is everything that's been generated on here. And if I was to do a stream here, and you can see this is effectively what HTTPS looks like. It's all encrypted, so there's nothing here of any real use. You can pick out odd little bits and pieces, but nothing really to show what the user was doing at this stage. Okay, so we're back, and what I'm going to do off camera is I'm going to just generate some traffic. You can see there's already some traffic coming through, but I'm just going to do exactly what I did before with the previous website, so with the vol web, and I'm just going to go through. I'm going to do sign up. I'm going to do test, and test as the login. And what you should see is there's some HTTP traffic being stored there. Again, just doing some things here. I'm going to go to the cart. And again, just putting in some random information into that particular website. Right. So I think we've got enough here. So I'm going to stop here. Behind the scenes, I had the art scanned. So what I'm going to do here is just press Q, and that should stop the sniffing at the back. And we've got some data here. So first of all, I'm going to do my filter and then HTTP. And then if I press enter, there we go, and that's all our HTTP traffic. And you can even see straight away some of the pages that I was looking at, so cart.php, comment.php, and things that I've added in there. If I scroll down a little bit, so you can see I looked at a page that had some pictures and images there. There was a form that I completed, which was the guest book. So if I look here, you can actually look at more detail what was actually inside this particular packet. And so on. If I was to click right here and then go to follow and then HTTP stream, again we can see all the information, but not only that, we can actually start to see the actual web page that was being looked at and what was on that particular page, and effectively what the server sent back to us. And if I carry on going through, you can see the request that went out. So cookie, login, test, and then we can see here test. So we can actually gather some information there. And then you can see the responses from the server, effectively what was sent back. So all of the information that I was doing off camera between the victim and the server has been recorded here in real time by our WireShark, and we can actually get the whole web page, everything that they saw, we can actually see that here. Okay. So we can show the data in a number of different formats. At the moment it's just being showed as ASCII. So we can see that there. And you can see everything that was done, even some of the HTTPS traffic and some of the encrypted traffic has come through. But as we go through, you can actually see that everything else is in plain text and can easily be read. So this is therefore proving that man in the middle attack was working and working effectively, as all the traffic between those two devices were passing through our machine. Now this is will obviously work on a wired device. At the moment I'm using a virtual switch and a VM, but it'll also work on Wi-Fi as well in exactly the same sort of way. Okay. So that is how we will do, or how you would do, a man in the middle attack.